noticed that you, and I'm glad to hear that you're well informed on the chromosome 2 fusion. So I showed the quote by Ken Miller, who said that, and I'm not saying that every evolutionist has to agree with that, but he did assert beforehand, before they discovered what looks like a chromosomal 2 fusion, that if there was no fusion, there was no ancestry with the great ape family, with the chimpanzees. I know you think humans are apes, so with the apes, or with the chimps and other primates, but
Can you present a reason why we're not?
well,
I mean, I'm being hypothetical.
okay,
Obviously, we're
right.
not talking about that right now, but
Okay, well,
when you get a moment.
I would just say, if I could demonstrate that there was no chromosomal 2 fusion, which is why I asked you some of those important questions, then just like Ken Miller said, no chromosome 2 fusion, then no ancestry with chimpanzees. And I think that
No,
would
I'm
kind of
comfortable
indicate
with
that we're
that.
not apes.
Yeah, I'm comfortable with that. Well, the thing is if the chromosomal 2 fusion isn't a fusion, then the alternative hypothesis would then subsequently be looked at, which is that the other hominoids gained the chromosome,
Right. Well,
or the chromosome pair. But to be very clear, for everyone out in the audience, you can
you do
go
believe,
check out.
yeah.
Yeah, because you were there. You were in the chat for my discussion with Steve McRae on this the other day, and
You guys
Ruhith.
were respectful. I enjoyed listening to that.
Oh yeah, yeah,
Ruhif, I have respect for. I've actually learned a lot from him. I often talk to him in comment section. So I
yeah.
did want to, without any interruptions, James, you don't got to worry. We're passionate sometimes. I did want to give you the opportunity to, because I watched that entire broadcast. I managed to get around to it, and I feel like there was a few things that you guys didn't touch on. So I was wondering if you could take some time, maybe, to, because you have spent a lot of time on the chromosomal 2 fusion,
Yeah,
to
sure.
answer those questions. I'm not sure if you remember the questions that I asked in the opening.
Cryptic centromere and satellite DNA, I believe.
Yes, maybe if I can find it. Yeah, so the first question would be, why is the telomeric region so degenerate and small? I did ask that in our first debate. I don't know if we got as far enough to get like a solid answer from you, and I believe you do have an answer, so that's okay.
Oh yeah, no,
As
no,
well
no. I
as
did not know at that point. I had not looked into it very closely.
I don't want to do, as they say, gish gallop. So why don't we start with
Yeah,
that
pick
question,
one.
and you take as much uninterrupted time as you want to. The satellite DNA is a very important question that I'd like to ask, but let's start with the telomeric region. Why is it so degenerate and small? And then I'll give a response after.
Ruhif actually explained this to me in our conversation with Steve. For those of you out there, in the human chromosome 2 fusion, in the center where the fusion site is proposed to have occurred, there are very degenerate telomeric sequences. Now, those telomeric sequences they usually cap the ends of the telomeres. Now, the reason why that's degenerate, and Ruhif pointed this out, I would go back and rewatch that if you would like to hear him explain it better than probably I will, is because you have a gradient on the ends of all chromosomes. So there's fresh new telomeres on the outermost point, then degenerate telomeres, because as we both know, when DNA replicates, the telomere sequences really take a beating, and then after that is when you start to have the classic regular chromosomal business that chromosomes do, whatever base pairs. So degenerate sequences, according to Ruhif, and he sent me some cool, or rather, he has some cool stuff on his channel that goes over this more in depth. But the reason is because that's entirely expected. In fact, all of the criticisms that I've seen regarding that by individuals like Tompkins, in the responses to Tompkins, they're usually like, why would you expect it not to be degenerate? In fact, if it wasn't, that would be quite weird, because that would suggest that when the fusion occurred, it completely ate up that degenerate site, when the degenerate sites, when they're exposed, is what causes fusion. Essentially, it's like having, I explained it like this when I was talking with Ruhif and Steve. It's like having two magnets. The ends of the magnets are degenerate telomeric sequences, and they want to stick together. But those new telomeres that are on the ends are like putting a cloth in between the magnets, so they can't. There's no real way for them to. It's like a weakened attraction. That's a very rudimentary way of explaining it. And interestingly enough, I'm just going to kill two birds with one stone here, because we talked a bit about satellite DNA.
Right.
Telomere fusions, which Tompkins objects to, the fact that telomere fusions can happen, which is what we see in human chromosome 2, they do happen. And Ruhif gave me two great papers for that. One occurred in pigs, and the other one occurred in equids. And what we find in both of those is the same thing that we see in human chromosome 2, which is telomeres stuck together like this, not satellite DNA, not satellite telomere DNA, telomere. So, and I can send you those papers if you would like, or I can put them in the description.
Yeah, of course, of course. I really appreciate that response. That was well said and very
I'm
concise. You know,
not as good as Ruhif did it. That's for sure.
for James's sake, I did time it. It was about 2 minutes, so I don't want him to think that I'm going on for too long as well. So we'll do equal time here. Actually, before I respond to the telomere one, the question I had was a little different about the satellite DNA because chimps have this very distinctive and exceptionally large satellite sequences at the end of their chromosomes, not the satellite DNA that Tompkins was talking about when the centromere breaks, for example. Because, like you said, if this is a telomere to telomere, you may predict that maybe there won't be that satellite DNA. So that was a little different question. I was asking where are those large 8 specific satellite sequences in the reputed fusion
Would
site?
Would you like me to, as quickly, under 30 seconds, explain that as well?
Yeah, you know what? Take 30 seconds, explain that, and then I'll try and address both at the same time. Take
Yeah,
your time.
I figured. Yeah, I figured you could just go ahead and just
It's
take
just
a
because it was,
chunk.
yeah, and I appreciate you answered the other satellite DNA objection, but this one was a little different. So take
Yeah,
your
sure.
time.
It was my mistake. I goofed it up in my head.
That's okay.
Yes. So the ends of the chromosomes, like I said earlier, those are the areas that are most frequently in the chromosome, sort of renovated, so to speak, if you want to call it that, because they just take such a beating in cellular replication, or so yeah, replication. So I don't understand why, given evolutionary theory and what it says, why it would be difficult to sort of conceptually, what's the word I'm looking for, conceptually square those two things together, because according to evolution, maybe it's different with sort of the creation outlook on it, but to be clear, from an evolutionary perspective, we expect mutations on those repetitive sequences on the edge of the telomere because they're renovated so frequently. So given the split between humans and chimps was 7-ish million years ago, that's quite a long it's similar to the degenerate concept. That's quite a long time to be developing sort of unique sequences. In fact, 7 is seems to me, on a totally an anecdotal note, seems to me like not that many, um, compared to, given you've got 7 million years. Sorry,
Are you
take as
saying
long as you need. I will
no, no,
drink my.
no, I just want to make sure you answer that last one, just to because I want you to feel confident in your answer. So the question on those very large satellite sequences at the ends of their chromosomes with apes, are you saying that? So are you saying those are absent in man because of the divergence time of 6 million years that would have got rid of it? That apes
I'm saying that if you have two chromosomes like this, right, and
right.
the ends are constantly changing to a degree, right, because of cellular replication and repair. Now, if they suddenly join together and that lineage continues onward, you're no longer getting a change in those end telomeric sequences. But if they stay separate like they are in the rest of the hominoids, those areas can still be subject to change and mutation. So I don't know why you would expect it's like any of the other, pick any difference between humans and chimps. And the reason that it's there, according to evolutionary theory, is because it's been 7 million years. So there's naturally going to, it's kind of like how we've noted that we've had the conversation before, how there are orphan genes that are unique to humans and there are orphan genes that are unique to chimps. Even though they share a great majority, there's still been time for unique novelties to accumulate. I'm sorry,
Okay,
that was a long
okay,
time.
so are you saying that those unique sequences that are those 8 specific satellite DNA sequences that should be seen flanking the reputed fusion site on both sides, if there really was a chromosomal fusion, after the split between the chimps and human ancestors, say 6 million years ago, are you saying the reason we don't find that, just I guess yes or no from what I gathered with what you were saying, is because of the divergence time? There's been enough time for that those 8 specific sequences to be lost. Is that more or less what you're saying?
Divergence or speciation, either. If you want to go for divergence, you've got 13 million years, maybe, depending on who you talk.
Okay. So the
So,
reason
but
we don't, so
yes,
the
it's
reason we
more or
don't,
less. Yes.
yeah, I just don't want to put words in your mouth. So you're saying that the reason we don't find those sequences around the reputed fusion site is because of the deep time since the fusion. They've been lost essentially for whatever reason.
Yes, according to the evolutionary paradigm, that tracks very well with everything else that we say.
Okay. Okay. I think, okay, so I wrote down as much as I could from what you said on the telomeres. So I think, contrary to what you're saying, even the original paper, and I would ask the audience to read it, even the authors there, the researchers, they emphasize a level of confusion and awe as to why the head-to-head arrays of repeats at the fusion site there have degenerated so much from the near perfect arrays found in telomeres that you described, right? So you can examine the fusion site for yourself. Anybody can do it. It's an extremely small segment of DNA compared to what should be present if a fusion actually did occur in the deep evolutionary past. I think the site is about 798 bases in size. Now, I understand with what you're saying is you would expect it to be degenerate. But even if there were two very small size telomeres that fuse, let's say, we're still looking at about 10,000 bases. And then if it were larger telomeres that fuse, then it's an even bigger problem, because obviously, since now we are looking at about 30,000 bases in size. And yet what we see in this signature is a pathetic 798 bases as the remnant of a so-called ancient fusion. But I think what you're saying is also weak as a rebuttal, because why would both of the fusing chromosomes be degraded to exactly the same point, yielding a minimized semi-symmetrical fusion? But I think the most fatal blow to what you're saying here, as a way to explain why the area is so degenerate, and I want you to comment on this, of course, is that we see these telomeric repeats, these internally telomeric repeats that you're pointing to, right? Because if we're saying that it's too degenerate, that implies that something's still there. So what is it? Well, we see those telomere repeats occurring throughout the entire genome. And these internal telomeric sequences are found to be functional. I've got many published papers here that's giving us functions for these sites. So they're binding to things called transcription factors. And what they do is they initiate the copying process of a gene into RNA. And what's amazing, it's kind of a double whammy, because that's yet more confirmation of our model, because we predict much of the genome, as you know, and many of these DNA sequences, for example, cytochrome C and other conserved genes, have multiple roles and multiple functions that play in the regulation of the cell and many other things, of course. So how do you explain the fact that that region is found throughout the genome? They're not found throughout the genome in relation to fusions. They're actually just functional sequences. So have you heard of that argument?
I want to give Erika a chance to reply, and I think what we might do is go into the closings right after that. So go ahead. The floor is all yours, Erika.
Yeah, sure. And standing, we're gonna have to talk about radiometric decay at some point. That is, to me, one of the biggest blows to the creationism model that there is. So at some point,
I do feel bad. I mean, if James wants to give us an extra 5 minutes of discussion to touch on that, I mean, I don't mind that. But I mean, it looks like I don't mind after you answer this question and even just briefly touch on the cryptic centromere. I mean, Are we running low on time there, James? I feel like we just started talking.
If you guys would like to, that's okay with me.
Yeah, Standing and I have a good time. Yeah, that works. 5 minutes. I'm sure we can at least broach the topic.
Yeah, let's do this. If you could answer what I said about the telomeric sequences, a really quick response to the cryptic centromere. I can do a quick response to that too. And then we'll give like the last few minutes to radiometric dating if you'd like to.
Yeah, well, and in fact, I'm not opposed to foregoing my closing necessarily if we would rather just have more conversation. But if you want a closing, I'm cool with doing closings as well. So it totally just depends.
Sure, you take your time, as much time as you need to address the points I made, and then we'll play it by ear.
Yeah, okay, so one, I noticed that you said that the fusion site is small compared to what we should expect, and I wrote down on what basis, essentially, like what are we comparing it to, what other fusion sites specifically, because according to the paper that I can link in the comments, the two papers actually, one on pigs and the other one on equids, specifically the zebras. It's very analogous. So, and it's a telomere fusion. So again, on finding telomeric sequences throughout the rest of the human genome in areas that aren't necessarily telomere specific, I would be interested to see, and I would predict that they are not found in the same bulk as they are in the center of human chromosome 2, because there are two things that make the telomeric sequences found in the center of human chromosome 2 so very important and so very indicative of fusion. And the thing number one is that there's so many of them, and the thing number two is that they exist there in accordance with the synotony, both behind and in front of the one on top, and I guess whatever, on top of the one on top and below the one on bottom, with synotony with the chimp chromosome 2A and 2B. In fact, when I was doing research for my most recent video, I found out that every single gene on the chimp side tracks to human chromosome 2 from 2A and 2B, if memory serves. They track over. Human chromosome 2 is a bit bigger, but mostly it's those pesky repetitive sequences that show up in most hominoid genomes. So, and with regard to the centromere, actually, I didn't have a chance to write it down earlier. I watched your conversation with Conspiracy Cats.
I'm not interrupting, I promise. You didn't really answer why those internally located clusters of telomere sequences are more common in the genome than just, where we're looking, and why they are now found to be extremely important.
Oh, no, but I did, because it's context specific. The fact that we're finding the telomeric sequence in the center of this chromosome, chromosome 2, in massive bulk in comparison to where we find them elsewhere in the human genome, is very, very indicative of a fusion site. And that is taken in accordance with the fact that the rest of chromosome 2 on either side of the fusion site tracks gene for gene with chimp A, chimp 2A, and chimp 2B. To be clear, I'm not saying that they're identical. The human chromosome 2 is a bit bigger. But again, it's those weird indels that make up the approximately 3% difference between humans and chimps. With regard to the centromere, what I was going to say was that I took a screenshot of your conversation with Conspiracy Cats, because I remembered this was from several days ago, that he had brought to your attention the fact that there is a cryptic centromere. Right. He just agreed that it was a cryptic centromere. But for those of you who want to know specifically, I suppose, the name of it, it's Q21.3 and Q22.1 regions. And I don't know why it wouldn't be cryptic. If you're sort of fusing two chromosomes together, would you not suspect that areas, given it's a centromere, that it's going to be at least partially written over or subject to the same mutations that the rest of the chromosome is subject to? I don't know why we would even expect it to be crystal clear. So I hope that, at least, even if you disagree, I hope that at least you got an answer to each of your
right.
questions.
It's not that I disagree that is the point or the area that they choose to look to, because I understand, and you obviously understand, that if there was a fused chromosome, two fused chromosomes, then you would have to demonstrate not only the legitimate fusion site, which is why we're talking about the telomeric region, but yes, also locate a disabled second centromere, the cryptic centromere, I guess you could call it. So
and there is a proposed
right,
cryptic second centromere.
So I guess my follow-up to that, and maybe a question to go along with it, is that so that 171 base pair repeat that characterizes primate centromeres, right, which would have to be found. It is that region, or that sequence, is found in many other parts in the human genome. And I have pointed out in the past, you've obviously watched the Conspiracy Cats debate, which I would recommend anyone watch that. It's too small and too human to be a remnant centromere, but you said that that's expected. But I think the fatal blow to that is that the entire sequence is internal to a functional gene, that ancient centromere site. So that means it would be impossible if that sequence had ever been a real centromere. But I think the fact that the cryptic centromere is a functional region inside a protein coding gene, encompassing both protein coding and non-coding regions, strongly implies that it's a key gene feature and not a defunct centromere, as you're pointing out here. How would you respond to that?
Why? Yeah, but why would it? I mean, there again, you can point to the fact that people who conventional science, when it proposes the human chromosome 2 fusion, it notes that there is on the center of chromosome 2, so the actual proposed fusion site, not even the cryptic centromere, that there is sort of a ghostly trace of a functional gene, the DXL11, whatever. I can't remember what it's called. I'm messing it up, but you know the one I mean.
The DXL11L2.
Yeah, the DXL11L2. Yes, that's very classic for again, it's part of telomeric family, which is gene family, which is very interesting. But for the same way that I would answer that question, why is it against the rules to have a gene move onto a fusion site or move onto a cryptic centromere? I would be interested. I don't know this, but what I want to look into is, can we find a promoter anywhere near the cryptic centromere? Because if I remember correctly, and the reason I said I'm going to look into it is because I don't, I feel like I remember reading at some point somewhere that the cryptic centromere is the functional gene that's on top of it is somewhat new. at least with regard to
I'm not interested,
evolutionary theory.
but remember that 171 base pair region is associated with other locations in the human genome that have no relation to a fusion event, and they're functional to the genetics is the point. So yeah, it's located internally of a gene, but
But
it's
they're not a
also, the
bulk.
sequence itself is functional, just like those telomeric repeats. So both of those sequences, the telomeric repeats and the centromeric repeats that you're pointing to as ancient telomeres and an ancient centromere, seem to be, the evidence is suggesting that they're just DNA elements that are found throughout the entire genome. So why are you cherry picking that to say that these are the remnants of an ancient fusion event?
Wait a second. I actually did not know this. Are you saying that centromeric repeats are found in the cryptic centromere, and then you're saying that it's not a cryptic centromere?
Right. Well, I'm saying
I
that
didn't
those
know that
aren't.
I didn't know there were centromere signatures there. Like I thought it was more of a location with maybe a handful. If you're comparing it to the fusion site, then why? I mean, my answer is exactly the same for both of those. I would imagine, and I
I'm just
don't know
saying the
this for
basis.
certain, that centromere, those centromeric repeats that we find there are found in larger quantities than they are elsewhere in the genome. Because you haven't said anything to suggest that at the telomere fusion site, right? That those little telomeric signatures that we find elsewhere in the genome are in the same quantity, because that's very important.
Good question.
You find these things like gang
I will answer. Yeah.
chromosomes.
I think we're both guilty of saying a lot of things, so sometimes we'll forget. Yeah. Those telomeric sequences, those internally telomeric sequences, they're found in parts of the genome in a few hundred base pairs in length, even a few thousand. And they're, for the most part, so all different types of lengths of, I guess, sizes, but they're associated with function. You know,
So
they're not.
they're found at the same size as they are
No,
in the
different sizes.
but not as large. None are found quite as large. I feel comfortable proposing that. Am I correct in that?
Are you saying not as large? I mean, the reputed fusion site region's only what, 798 base pairs?
I'm saying, do you know for certain that the same number of telomeric repeats that we find at the proposed fusion site are found elsewhere in the human genome and are functional?
Yes, some are smaller, some are
But none
more.
are the same size, are they?
The same. They could
Because
be. I mean,
that's key.
those sequences that are found there, I'm saying, are just found all throughout the genome, just like
yes,
the
but not in the same. That's what I'm going to assume that that's what you're saying, because I feel like I'm not getting a clear answer. Would it be okay with you if we quickly touched on radiometric dating here?
Of course. Because I don't want to leave anything hanging. I don't want you to think that I didn't answer that question. I'm not exactly sure how large the sequences are. I'm just saying that there are many other internal sites all over the genome where telomere sequences occur in like this, and that are functional. And one last point I wanted to say in response to your the centromere sequences is that actually Tompkins pointed this out, and then I'll even give you the last word on the chromosome 2 fusion before we go into the dating. But he pointed out that, and I want to see your thoughts, that centromere sequences are made up of variants of alphoid DNA sequences, a class of DNA sequences, right? There are different variants, though, of these alphoid sequences that can be placed into different groups or categories. So some types are found all over the genome, while others are specific to centromeres. This is the key issue on what we're discussing here. The type of alphoid sequence found at the cryptic centromere site on the human chromosome 2 does not actually match alphoids associated with functional human chromosomes. So there's no consistency there. Like, how would you, what are your thoughts? Like those alphoid sequences, I want to make it more clear, found at the so-called cryptic centromere are a type commonly found in the human genome outside centromeres, which we can just label them as higher order repeats. So like, what are your thoughts on that?
I mean, my question would be, when you're finding these in other locations, it's very similar to my question with the telomeric sequence. Are they found in the same volume? And again, I think this is left out. So that's sort of my answer to that. But as a tag on for those of you watching,
I would say yes. As an answer, I would just say yes. In the same volume, greater volume. I mean, all parts of the genome, these sequences are found in all different sizes, all different quantities. They're found to be associated with important functions in the genome. That's why Tompkins is saying, okay, this area is degenerate with the telomeric sequences. Well, there still is, a 798 base pair region there. What is it? And then he's discovered that these sequences are found throughout we've already talked about this, but my answer would be, yeah, size-wise, quantity-wise, all different types of quantities throughout the genome. But exact numbers, I'm not sure.
That feels a little bit like a either put a pin in it or like a cop out, because it's like, obviously if we don't know, because I don't know, I will tell you right now, I do not know the number that is found outside of this telomere or outside of the cryptic centromere. It's something that I want to look into.
Sure.
But if we don't know for sure, then we kind of just have to say we don't know. Saying they're found in all sorts of different sizes is somewhat irrelevant, because what I don't know is whether or not finding larger sequences is equally as sort of precluded as a potential analog as too small sizes. Like, is it the perfect size for a telomere fusion? If I remember correctly, and I could be incorrect on this, but I'm fairly certain, according to those two papers on telomere site fusions in equids and in pigs, it's quite analogous.
Well, real quick, I did quote earlier from the actual paper of the chromosome 2 fusion. They did ask, why is this area so degenerate? And even if it was too small, degenerate telomeres, you should still see remnant telomeric sequences of at least 10,000, but all we see is 798.
But standing in the original paper of finding Lucy, Australopithecus afarensis, they were like, well, why is it that the pelvis looks like this? I mean, if I remember correctly, the human chromosome 2 fusion paper was like either in the early 80s or the early 90s. Like, to suggest that them not knowing what was going on is somehow indicative of the fact that now there is indeed an answer to that question. Other than saying, well, I don't like what Tompkins does, which is saying, I don't like it because XYZ, or I disagree because XYZ. But I don't think you can just point to a past paper and say they didn't know what it was and use that as evidence to bolster your point.
Well, and I don't want to recycle everything that I said in my response as to why I believe that argument fails. We'd probably just be repeating ourselves there. And
we would be. I'm just saying that it's kind of pointless to bring the paper up, the fact that the original discoverers of the fusion site were like, well, we don't know why it's degenerate. I very much doubt that if I went back and read that paper that they said, we don't know why it's degenerate, therefore it's not a human chromosome 2 fusion. I think that, like most scientists do when they don't know the answer to the question, they say, well, we don't know. Why is it like that? Maybe we'll find an answer. But then I don't think it's... Oh, go ahead.
But even in that region, even the repeats that are found exist mostly as independent units and not actually tandem repeats. And I believe it's only like 10 intact TTAGG telomere sequences and only 42 CCTAA intact reverse complement sequences that exist. So it seems like all the evidence, when you actually look at it and examine it, and the fact that these sequences, as I've stated, are found internally all over the genome and have various functional roles, that does seem to falsify. I understand that when they first saw it, they were thrown off. Why is this area so degenerate?
Right.
So they explained it away, like you said. But when we examine it even further, we see that the evidence does not support that claim as to why it's so degenerative.
We don't see that. We have an answer for the degeneracy. It's just very...
it doesn't hold up. It doesn't hold up.
But why not?
Well, I've given probably about 5 or 6 reasons.
The degenerate sequence specifically. Why does it not... why is it completely precluded in your mind? Remember the magnet example that I gave? When we do find the tips of chromosomes with degenerate telomere regions and then intact telomere regions, why wouldn't you expect to find degenerate telomeres in the middle if once you strip away those pristine telomeres, it makes it easier to fuse? It's like
because they're not telomeric sequences. I've already said this 5 times. And even if they were, why would both of the fusing chromosomes be degraded to exactly the same point, yielding a minimized semi-symmetrical fusion? So I get that that's the philosophy.
Did you just say they're not telomeric sequences after saying, why are the telomeric sequences so degraded?
I'm saying that the area that is being claimed that these are the remnants of ancient telomeres is too degenerate. Now you're explaining away the degeneracy, but I'm
Yes.
showing you that they're not even the remnants of an ancient chromosomal 2 fusion, because these sequences are DNA elements found throughout the genome. That's the thing. Just like the sequences, I think it's 171 base pair sequences or base pairs that's found at the so-called cryptic centromeric site. Those are also found spread throughout the genome. And I get your question is what's the quantity, but those are functional DNA elements as well, as my point.
I think
Yes,
we've gone to about 5 minutes, so I'm going to give Erika a chance to respond, and then we will go into closings.
Yeah, sure. Okay, so and we'll have to do that radiometric decay another time, Standing, because I feel like you're running from me on it a little bit. But
I'll address it right now if you'd like me to.
I've heard enough of that. All right, we're going to go back to
So-
Erika.
I'll address it in my closing.
Sure. And you can.
And then we'll have a separate debate on it. Age of the Earth, round 4.
Oh, please! I would love to chat with you on Age of the Earth.
You know what? You've heard it today. Round 4 is Age of the Earth. In my closing, I'll briefly touch on the isochron. Sure. I got 3 minutes, and then we'll schedule that.
Yes. So I will, as James said, take the last word on this. So what I heard was, why is the site so degenerate? And then I said, well, it's degenerate. The proposed idea is that it's degenerate because that's what we see in other species, XYZ, explaining it with magnets. And then you said, but that can't be because they're not telomeres. And then my answer to that, of course, is, well, how do we know that? Why is it being proposed? You say, well, it's because we find little DNA elements that are very similar to what we find at the center of the telomere. And then I say, are they in the same number? And your answer, as you very honestly said, and I say very frequently myself because it's so common, at least for me, that you didn't know what the size range was, what the typical size range was for what we would expect to see at a telomere site. And then I responded to that by saying, if I remember correctly from Ruh's video, which is not a certainty, while the previous stuff I felt decently confident on, it's fairly analogous to what we see in other organisms. And that's I do not think that there is anything that I have not at least provided an answer to. Those of you out in the audience, you can take that as you will. So Standing, please close for us, and I will give my little closing after that, and then we can do Q&A.
All right.